put this to the power of 0, what do I get?
1.
Yes, because anything is to the power of 0. Very good. If I put it to the power of 1, what do I get? Very good. What a start. If I put this to the power of 2, what do I get? A squared plus 2ab plus b squared. Let's do it out properly, yeah? A plus b times a plus b. Okay. If I do it to the power of 3, what do I get?
A cubed plus 2b cubed plus a squared plus b squared plus
Okay, if you
cubed plus 2
if
b squared plus 2a squared b plus b cubed.
if we're not too familiar with it, we can just work it out. We're just going to multiply it by itself, and then we work it out. So we get definitely a cubed. We multiply them all by a. You get 2a squared b, I'm multiplying by a, plus ab squared. Now multiply by b. You get a squared b. You get a plus 2ab squared, and you get a plus b cubed. Okay, so, but there's common things here. So now that and this can be added together. So you actually get a cubed plus 3a squared b, and this plus 3ab squared plus b cubed. Okay, I'll put that in here. A cubed plus 3a squared b plus 3. All right. There's always a pattern. Well, yeah, we go to the power of 4, but we try and do it a little bit quicker.
A to the power of 4.
Yes. What's the first and last term? That's the easiest.
B to the power of 4.
Very good. So we're almost there. There's going to be some in the middle. How many terms?
Yeah, 4a cubed.
4. Okay. So that's, you're saying 4a cubed b squared. There's good. All right. Almost. Let's just think about the number of terms. When it had 0 at 1 term, when it had 1 at 2 terms, 2 is 3 terms. Power of 3, it has 4 terms. So power of 4 must have, it looks like it's going to have 5 terms. Now we could do this long way, but look at the patterns of, let's say, the powers, first of all. This one went a cubed, a squared, a, gone. See that? And this one went nothing, b, b squared, b cubed. So what's the a power going to be in this next term? And you had it right. A cubed. What's the b going to be? Just b, you know. And you're predicting 4 in front here. You're right. Right. Let's look at the, yeah, what's the next one going to have as an a power? A squared, b squared. Very good. Because the a is going down and the b is coming up. Starts at 0 here, 0 power. B to the power 1 if you want, b to the power 2. So we're missing a b to the power 3 here in the next one. So we've got a and then b cubed. B4 at the end. Okay, I haven't put in, they're all going to be plus because there's no minus here to make it minus. This is going to be 4 or this is going to be? This is going to be 4. Okay, very good. And this is just going to be b to the power 4 because that follows this pattern. This follows that. That's a to the power 0. But what's this middle term going to be? 6. Very good. How did you get 6? Yeah. So let's just look at the coefficients. Let's pull the coefficients, the letters in front of a and b out. So there's only 1 here. This is 1 and 1. The coefficients here, 1 and 1. Yeah. This is 1, 2, 1. This is 1, 3, 3, 1. This is 1, 4, 6, 4, 1. What's the next line? Without even thinking about it, what's the next line going to be? 1, 5, 10. No. No. What's the pattern created here? This is a famous, does anyone know the name of this triangle? Pascal's triangle. Very famously, where 3 and 3 add to give 6. 3 and 1 add to give 4. 1 and 3 add to give 4. 1 and 4, 4 and 6, 6 and 4. Yes, I know. 5 and 1. So the next line, we can already do the coefficients for it. A plus b to the power of 5. Now we have all the coefficients. Now we've noticed the patterns in the powers. So we could probably rattle this off quite quickly. A5. What's the next term? 5 is the coefficient. What's the a power? B1. Next one, 10. 10, a squared, b cubed. So I'm getting these numbers from here. Then 5, a, b4, and then b to the 5. So now all of a sudden, we're getting much quicker at multiplying a binomial, or squaring, cubing to the power of 4 to the power of 5. I'm getting far quicker at it. You can probably do the 6th line if you want to add the 6th line here. 1, 6, 15, 20, 15, 6, 1, and then you do the same process. So what have we noticed so far in the patterns? How many terms are there compared to the power?
One more. Plus one.
One more. The powers go in descend. The first one goes in descending powers.
Oh, and
The second one goes in ascending. It's, well,
yeah. That goes 5, 4, 3, 2, 1.
the powers, no, that's not where the, but it's, yeah, that's good thinking, but it's actually not where the factorial, because these are added, not multiplied. And the b power goes up 0, 1, 2, 3.
So this is binomial.
This is binomials, yes.
Whoa.
So the questions come when we get some sort of values and we're trying to find a particular term in the sequence. So this would continue on like a plus b to the power of 11 you could do. You could do it now. You'd have to continue this triangle down to 11. This triangle can be found using any number in this triangle can be found using that factorial stuff we were doing.
Can you find any number in it?
Yeah. Okay. Using the, like, we can find in the 11th row the third one in using that factorial thing that we did. But we come to that. So let's look at a question and see can we do it. I'll remove all this. Okay. I want to fully expand this. I want to fully expand this without having to multiply x plus 3 times itself 5 times. Do we think we could do it?
Not without your help.
Yeah. Well, we'll do it together. Right. I'm going to keep this here. Which one of these do you think is going to be useful? Which line of this? The one with 5 in it, yeah, this one. That's 5, and you can see that this is 6 coefficients, let's say. And this is, with power 5, we need to have 6 terms, so each of them has to have a coefficient. All right.
Wait, can you connect the lines? It's so confusing.
Connect the lines here on the next.
It looks like 2 1s and then a 5. No,
Oh, here, yeah. Okay, yeah. All right. Okay.
It's confusing.
Let's do this. Let's go with the x power first. Let's just descend the x power. Am I x4, x3, x2, x1, and 0, yeah? So I'm descending the x power, and I can ascend the second power.
So you don't actually do like 9, 3, 9.
We are gonna end up squaring. There's nothing with this one, but this is 3. This is 3 squared. This is 3 to the power of 3. This is 3 to the power of 4. And this is going to be 3 to the power of 5, our last term.
And then in front of it.
Now in front of it, we've got a bunch of coefficients we need to install. 1, 5, 10, 10, 5, 1. 1, okay, that's okay. 5, I put these two close together. 10, 10, 5, well, 1. Plus, 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 plus. Now, if this was a negative 3, you just put in negative here, and every second one would end up being negative, wouldn't it? But we're done. Okay, that's a bit messy, but we're going to tidy it up. The first term is definitely x5. What's the second term?
3. Oh, 15.
15x to the power of 4. What's the next one? 90. Now, where does the 90 come from? Yeah, there's a 3 squared here, which will be applied to, like, this whole term is 10x cubed times 3 squared. So might as well square the 3 and multiply it by the 10. So I get 90x cubed.
And 270x.
Yep, so that's 27 times 10, 270x squared. Next one.
Come on, Josh, you got this. 405x. Yeah, 405x.
So it'll be 81 times 5, so 405. 405x plus 243. Now, we would have been a long time trying to multiply that out 5 times like you would have done in GCSE, but now we can do it in a, well, it doesn't take a second, but systematically you can do it. But oh.
We're gonna get questions like this.
Oh, let's put 8. Yeah. Okay. The difference between this question and this question is, maybe it's obvious, maybe it's not. Do we need to fully expand the whole thing out?
No.
No, we do not.
Oh.
We could, but they're only looking for one term. Like if we looked for the x cubed term, you'd only have to find this one. You don't need to find any other one.
So what you would do is like you kind of expand that triangle, and then times negative 2 to the power of 3 is like.
Okay, well let's try and figure out which term we need. We know that the first part of the binomial is x, and the second part is negative 2. Both of those end up going to a power, don't they? Like it's going to be 4, 3, 2, 2, 3, 3. What do these two powers always have to add to? Did we notice that?
8.
8. They'll have to add to 8. Why? Well, in this one, all the powers added to 5. 5, this was to the power of 1, remember? So 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, 5, always added to the power of 5. So this will have to add to the power of 8. Now, I already know I'm looking for the x5 term. So I know that this has to be 5. So what must the minus 2 be to the power of? 3. Okay? But I'm missing this number in front. What's this number in front going to be? Well, perhaps the triangle continuation will help. 21, 35, 35, 21, 7, 1. Is this the line I need? No. I need the next one, don't I? The one has 1, 8. Here's the hint, the 8 here. That's the way this goes. 2, 3, 4, 5, 6, 7, 8. 8 is here. 8 is here. So we have 1, 8, 28.
You just add a 1, like you decide on.
Well, it came from, this is A, remember A plus B, when it's the power of 1, 1 and 1. The first and the last term, the coefficient ends up being 1. Now this one ended up 3, 5 times 1. But it's always x5. It's never like anything else. Okay. 28. 56. How many of these do I need to do? I'll do them all. 56. And we decide which one do we use, though? There's a bunch of numbers here. Which one do I use for this one in particular? The fifth one?
Yeah. No.
Well, what would this correspond to? This would be x to the power of what?
This would be x0.
That'd be x8. The first one descending.
Yeah.
So this would be x7.
Oh, the third.
This would be x6. And this is x5.
Oh, yeah.
So 56.
And then
Oh, you don't
And
have
then
to
you,
expand it?
well, you should expand it. If you're looking for the term, these two we know can be combined. 56 times what? 56 times.
-8.
So -8 times 56. Anyone do that fast?
-400.
Yeah. And that's the fifth term of that full expansion. The x5 term. It's actually the fourth term.
Wait, I don't get how you. Oh yeah, because it adds up to 8. That's why it's valid.
Okay. So now we can find any term in a binomial expansion with this kind of system. We should be able to find any term. Let's just recap without going to the slides. Let's keep this up and we go here. No? So when I get a binomial, like this one, let's say to the power of 10, I know that each term will be made up of a combination of those two things multiplied together. These two powers add to what? Add to 10. And this number in front, this coefficient in front, what can I say about it?
Triangle.
You can get from the Pascal's triangle, yeah? If you want. Pascal's
Is there a formula?
triangle. Yes. Yes. And the formula uses factorial. And that's why we did factorial first.
Wait, does it?
That's one binomial theorem. That's one way of writing it. There is another way of writing it that's in your formula booklet, which is not as useful. Do we have it here? Where did I put it? Oh, I have it in my old slides. Okay, no. Okay. We're going to do part B there. Can you do that one?
Oh, sure.
Find the expansion. So this is more difficult now. Can I remove this? Okay. So this one, I want to find a particular, the fifth row of Pascal's we already have here, so we don't need to do that. But we do need to expand now something a little bit more difficult. So it's 2 over x.
Wait, Mr. Pauls,
Yeah.
how do you know, like, which two numbers for the add to 10? Like, before you did it's 5 and 3, how do you know it was 5 and 3?
Because it looked for the x5 term.
Oh, okay.
Now on this one, if you have to do the expansion, it means you got to do the whole thing. So you don't need to worry about that so much. It's got to do the whole thing.
That's annoying.
Yes, it's annoying. So try it though.
No, but like you do x times -2 over x, so it's just -2. So then while you're multiplying it, you're simplifying it.
Yes, you have to simplify a lot at the time because one x power is going to cancel out with the other x power. But this is an important one because this is where the more difficult exam questions usually has a combination of a fraction and one not as fraction. So can you expand it? Go for it. Do it now. I want each term. The first term is just going to be x to the power of 5. I know that the next term is going to be x to the power of 4. But it'll also have -2 over x to the power of 1 in it. Yes? The next term will be x to the power of 3, but it'll have -2 over x to the power of 2 in it. This term, x to the power of 2. So this one's increasing in powers. I'm going to run out of space again. X. And the last term is -2 over x to the power of 5. Now I left a lot of gaps here. That's your starting point. Can you do the rest?
But can't you already do like, oh, you can't automatically do it to the negative?
No, every second one's going to be negative, won't it?
Yeah.
Yeah.
Every second one's negative.
Yes, it will be negative because when this is to the power of 1, it's going to be negative, but when it's squared, it'll be positive. And when it's to the power of 3, it's be negative. When it's to the power of 4, it's positive, and so on. But that's when I simplify it. This is not it simplified yet. I'm going to put in the coefficients next using this row of the Pascal's triangle. And then I'm going to simplify each term as simply as I can, which means combining indices, which is like question 1 from our exam the other day. Can I combine indices when they're multiplied?
I think a lot of us got that question wrong.
Yes, you did, yeah. First question. When I was multiplying by x to the power of minus 1. Don't tell Josh. That demotivated you?
Yeah.
Oh.
First one, I was like,
I'm sorry.
Wait, am I getting the exact same test?
Yeah.
Oh. Alright.
Hopefully you'll do really well.
I'll actually try.
Did you not try it last time?
No, I mean, like, if I'm doing the exact same test, it's asking what they would know.
Okay, maybe you're at this stage. 1, 5, 10, 10, 5, 1. Now can we simplify this all at the same time? Okay. Which? Yeah, so we're going to combine the powers and then make it 1 power, yes. So my first term is definitely x to the power of 5. That's not too bad. Prize for the second term?
Wait, whoa. Oh, so wait, would the second term be negative 10x cubed?
Yes. Negative 10 from the 5 times the negative 2 here. And then the x4 divided by x1, they'll subtract these powers to give x cubed. Does that make sense? x4, and this is going to be x to the power 1. You're going to have x4 over x1, and that gives x3. 4 take away 1. What's the next one?
Plus 40x.
T's? So 10 is going to have to be times by minus 2 squared.
Yeah. Negative 40.
So positive 40, no? Okay, yeah, because minus 2 squared is positive 4. And then what's x cubed over x? So that'd be x cubed over x squared, which is the same as x. Yeah. All right, what's the next term?
Minus 20 over x.
If you notice, it's going to be minus anyway, yeah. Minus 20.
Over x.
Minus 2 needs to be cubed.
Oh, oops. Minus 8.
Yeah. So minus 2 cubed is minus 8 times this 10 gives minus 80. Now you can write x to the power minus 1 if you want, or you can just write over x. Where does that come from? Well, if I just did the x powers here, I have x squared, and then this x is cubed, so I have x cubed, like that, which is, this one's winning, so this is just 1 over x, isn't it?
Wait, will we ever have to be like this to the power of like 9 or 8?
Yeah.
Oh, that's so much.
But usually, no, well, okay, the full expansion, no, up to power 5 or 6 to do a full expansion, but then they look for particular terms when it's x, or to the power of 8, 9, 10, 11, 12, they look for a particular term. What's the next one then?
Next one, plus 80 over x.
Yes, plus 80 over x something. X cubed, yeah, because this is going to be x to the power of 4. X over x to the power of 4 is... And the last one then is minus...
2 over x.
Hmm?
No, it's 32. How did we get 85?
Just so happens, well, minus 2 cubed is 8 times 10, and this is 5 instead of the 10. Yes, half, so it does make sense. So 2 to the power of 5 is 32, isn't it?
Yeah.
So minus 32 over x 5. Okay?
Why do we have to simplify it that much?
This is very fun.
Maybe not on a Tuesday evening. I just want to get up what the formula is. I don't have it. I have it in my other set of slides. Okay. Okay, so the formula should look easy, right? Yeah, no, of course not.
Yay!
Sigma notation is in there. There's like a what? Well, it looks like vectors is in there. What on earth is this?
Dude, this looks like enchanting language.
Okay,
Minecraft enchanting.
this is the same formula I used in SL, so just in case you're, it's the same formula. This is not HL specific. But it does make sense. If we slow it right down, it does definitely make sense.
So by the end of the 2 years, we'll be able to speak a calculator.
Yeah, pretty much. You'll turn it into a computer. Right. Just look at the a power. So this is just in general, a plus b to the power of some n. It says here the first will be to the power of n, and the second will be to the power of n minus 1, whatever. So if it's 5, the next one's going to be 4, and so on and so on and so on until we reach the end. That's what this bit in the middle is.
What does n over r mean?
Yeah, so what does n over r mean? It is the power. So see that n is the power, and or is its position, which one you're looking for. So which position is it in the Pascal's triangle, first, second, third, fourth, and it is mathematically it is NC or n choose or. What it is, it has a formula in your formula booklet, which is the one I wrote up earlier, n factorial over or factorial n minus or factorial, and that's n over or. There's also a button on your calculator that will do it for you. Yes, exactly. The or is the place, n is the power. So when we do it automatically. So when you want to find the x, let's say we want to find the x7 term in our general thing here. We're doing a lot at once here, by the way. We're doing the whole binomial theorem at once. But you're getting the hang of it without the formula. I'm showing you don't need the formula. The formula looks complicated. But if we want to find the x7 term of this expansion, so you could expand it all, you could find this one. If I want to find the x7 term, I know that it's going to be 7 here, yeah? And the minus 3 has to be to 3, yes? Okay? Now, it would be hard to do the full expansion binomial all the way down to 10. That will take forever. So there's a quick way of getting that number. And you, instead of going from Pascal's triangle, you can just go 10. And what do I put here?